Hey math kids, today we're going to be in section 10D and we're going to talk about theoretical probability. It has a lot of similar properties. We're still going to think of probability as what we want over the total. Okay, but so we're just going to kind of work with that. Your book words it a little bit different, but really that's the same idea, what we have. So we're going to example 6. It says a ticket is randomly selected from a basket containing 3 green, 4 yellow, and 5 blue. Blue tickets, and determine the probability of getting, so we want to get a green ticket. So probability of green, once again, there's 3 of the thing we want, and we divide it by the total, so 5, 6, 7, 8, 9, 10, 11, 12. So 3 over 12, which becomes 1/4. Okay, the next thing we want is a green or yellow ticket. So green or yellow, we have 3 plus 4 over the total, which is 12. 3 plus 4 is 7. So we get 7 over 12, and that's our probability. Okay. Next one, we want to know the probability of an orange ticket. Since there are no orange tickets, what we want is 0 divided by the total, 12. 0 divided by 12 is 0. And the last thing on this one, a green, yellow, or blue ticket. Green, yellow, or blue. Since green, yellow, and blue, 3 plus 4 plus 5 over the total of 12, that's 12 over 12. So our probability is 1 or 100%. Okay, let's move on to example 7. It says an ordinary 6-sided die is rolled once. Determine the chance of getting so we have a 6-sided dice. And we want to know probability of getting a 6. Well, there is one way to roll a 6 out of a total of 6 outcomes. And so the probability of rolling a 6 is 1/6. Now, what about not getting a 6? So probability of not 6. Well, there are 5 numbers that are not 6 out of a total of 6 numbers. So the probability would be 5 over 6. The next one, probability of getting a 1 or a 2. Probability of getting a 1 or a 2. Well, there's 2 ways to get those numbers, and there's a total of 6, so that would be 1/3. Now, not getting 1 or 2. Not 1 or 2. So there are 4 numbers on a standard dice that are not 1 or 2, and out of a total of 6, and so that would be 2/3 chance. Now, another way we could have approached this, we could have looked at this, so we had 6, which was 1 out of 6. This would be everything else. So the 1 and the 5 should add up to 6. So we have 1/6, and then 5/6 because it's just not 6. Same thing here. We ended up with 1/3, and then this was just not this thing. So not 1 or 2, and this is 1 or 2. So we just used the rest of it to make 2/3. I don't know if that made sense, but we can talk more about that in Math Lab if you want to. Now we're going to move on to example 8. It So it says use a two-dimensional grid to illustrate the sample space for tossing a coin and rolling a dice simultaneously. Hence, determine the probability of... So let's just draw the diagram first before we move on with that. So I'm going to say this is the coin. And we have tails here, heads here. Then we have 1, 2, 3, 4, 5, 6. Okay. And all of these are possible. Alright, draw our grid. You don't absolutely have to draw this grid, but I think it looks kind of good. Okay, so that's our thing, and then it wants us to know the probability of tossing heads. So, probability of getting heads. So when we look at it, we can see that there's 1, 2, 3, 4, 5, 6 ways to get heads. If we count all the dots, not including these, I'm going to erase these because they're kind of confusing. Not those ones. Okay. So if we just count all the dots, there's 12 dots. And so we have a 50-50 chance of flipping heads. Okay, part B says tail and a 5. The probability of tails and 5. So tails and 5, there's only one way right here. And so that's a 1 out of the total of 12. And so that's our probability. And then the last one, we want to know tossing a tail or rolling a 5. So probability of tail or 5. So that's going to be all of these, because all those are tails. And then 5 is going to be all of these. So we just count how many dots line up with that. So 1, 2, 3, 4, 5, 6, 7 out of the total, which is 12. And that is our final answer. Okay, we're going to move on to example 9. It says display the possible results when 2 dice are rolled and the scores are added together. Okay, so we'll make a grid. We'll just say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is die 2, die 1. So if we add these, it's 2. If we add these, it's 3, 4, 5, 6, 7. And then 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, 12. Okay. So we got that, and then it says, hence, find the probability that the sum of the dice is 7. Okay, so we just count how many 7s we see on this diagram. So it's 1, 2, 3, 4, 5, 6. So there's 6 ways to get what we want. And there are 36 total, because we'll just do 6 times 6 to see there's 36 outcomes. And so if we reduce that, it's 1 out of 6. Okay, now example 10, which I think is the last one. Let's see. Nope, it's not. We have 2 more. Okay, so example 10. In the Venn diagram, so let's draw this. It's not very good. Okay. Draw the Venn diagram. We have the universal set. And we have 1, 2, 3, 4, 5, 6, 7, 8 dots. Then we have 1, 2, 3, 4. Okay, so we have this Venn diagram. So it says, in the Venn diagram, the universal set U is the children in a class. Each dot represents a student. The event B is that a student has blue eyes. Find the probability that a randomly selected child has blue eyes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So probability of blue is going to be 8 for what we want. And then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we have 23 kids in the class, and so it's just going to be 8 over 23. Okay? Now, does not have blue eyes. So that's just going to be everything else. So it's just going to be these dots, which are 15. Not blue. So that's 15 out of 23. Bad 5. And that's it. Okay, so we're going to move on to the last